I'm going to talk about rotations of sets of points. All right? Rotations move points along circles. So when you're wondering what a rotation is, it's nothing more than moving a point on a circle to a different point along that same circle. Okay? To specify a rotation, an angle a direction, and a point of rotation are required. All right, so an example will make this more clear. Let's rotate point A, okay, with respect to angle theta, and the direction will be the clockwise direction, and the point of rotation is going to be a point P, which I'm going to draw in a second. Okay? So if we rotate point A with regards to the point of rotation P, the angle theta, and the clockwise direction, it's going to end up at some new position. Okay? Let's call that new position A prime. All right? A prime, the position of A prime will be such that the following is true. The line segments AP and A prime P are the same length, and they define an angle with a measure theta. All right? If I changed theta, then the position of A prime would change such that it's still the same distance from point P. Okay? Notice that for all of the rotations of point A with respect to point P, they're all going to lie, all the possible destinations are going to lie along a circle. Okay, that's why I said that rotations move points along circles. All right? Now, if I rotated point A by an angle theta in the counterclockwise direction, then I would have ended up at, let's call this point A double prime. Okay, so A double prime would have been located something like right there, and we're still rotating by an angle theta, we're just rotating in a different direction. So AP, the line segments AP and A double prime P still define an angle with a measure of theta. Okay? All right, now let's do some examples in a coordinate plane. Let's define point A to have coordinates 1, 2. All right? So let me finish drawing my coordinate plane. And so I'll place point A at 1, 2. And let's do the following rotation. Let's rotate 180 degrees counterclockwise with respect to the origin. So the origin is the point of rotation. Okay, so the line segment with endpoints A and the origin, and the line segment with endpoints the origin and the final destination are going to have the same length, and they're going to define an angle with a measure of 180 degrees. So let's call the destination A double prime. All right. Can you see that A double prime is going to have coordinates -1, -2? So that already is an interesting pattern. If I do a 180 degree counterclockwise rotation of a point with respect to the origin, then what I essentially do is change the sign of the coordinates of the point. So 1, 2 became -1, -2. Okay? Now, let's see if we can figure out a pattern for a 90 degree rotation. All right, so let's do a 90 degree rotation in the clockwise direction with respect to the origin. So the origin is still the point of rotation. And so let's call this destination A double prime. Okay, so the A double prime is going to, excuse me, I meant to call the first one A prime, not A double prime. So let me fix that now. So the first rotation gave us A prime. Now this rotation, I want to call this destination A double prime. Okay, so the line segment that I just drew has the same length as the other two line segments with endpoints at the origin. All right, and so what are the coordinates of A double prime? All right, so in the easiest way I can think of to understand the coordinates of A double prime are to focus on a rectangle with vertices at the origin and point A. Okay, so think about rotating that green rectangle with point A at a vertex 90 degrees clockwise. Okay, if I did that, I would end up with the following black rectangle. Okay, so point A was on the vertex of the original rectangle. After I rotate it, it's still going to be on the rectangle. Okay, in fact, A is going to move to A double prime. A double prime is on that black rectangle. Okay, now when I rotate a rectangle, the size of the rectangle doesn't change. I think you'd agree with that. The green rectangle had a short side of length 1, a long side of length 2, and the same is going to be true of the other rectangle. It has a short side of length 1 and a long side of length 2. Okay, and since A double prime is on a vertex of that rectangle, it should be clear that the coordinates of A double prime are 2, -1. Okay, so what did we learn from this? Okay, if a 180 degree rotation simply changed the sign of the coordinates, a 90 degree rotation changed the positions of the coordinates. Okay, it swapped the coordinates, but it also changed the sign of the final y coordinate. Okay, so in other words, I started out, the point A was had position 1, 2. Okay, the final position, I swapped those, so I get 2, 1, and then I changed the sign of the 1, so I get 2, -1. Okay, now let's do one other example of a different 90-degree rotation. Let's do a 90-degree counterclockwise rotation. And we'll do this one about the origin as well. Now you can do rotations with regards to a coordinate plane with other points of rotations besides the origin. It's just that the origin is easiest to work with. All right? So let's call this one a triple prime. Okay? And so a triple prime is going to be just as far from the origin as a prime and a double prime. And let's see if we can figure out the coordinates of that one. Okay, so this time think about rotating the green rectangle about the vertex located at the origin 90 degrees counterclockwise. Okay? If I do that, I'm going to end up with the following rectangle. Okay? So A is still going to be at a vertex of the rectangle. In fact, A is going to be at the position of A triple prime, which is on the rectangle. Okay? The rectangle still has the same dimensions. All right, short side 1, long side 2. So hopefully that makes it clear that a triple prime will have coordinates -2, 1. Okay? Now, the point of all this was to see the patterns. Okay? Let me repeat. 180-degree rotation about the origin simply changes the sign of the coordinates. Now I leave it to you to figure out why that's true, whether it's a clockwise or counterclockwise rotation. Okay? Now for a 90-degree rotation, what happens is you swap the original coordinates, and the direction tells you which final coordinate you have to change the sign of. Okay? For the clockwise rotation, notice that we changed the final y-coordinate to be negative. On the counterclockwise rotation, notice we changed the final x-coordinate to be negative. All right? So let's do an example. Or let me have you do an example. All right, so I'm going to define a triangle. I'm going to define the vertices of a triangle on a coordinate plane. Let's define triangle ABC, and let's call point A, or we'll put the position. We'll say that point A is at the origin, so it has coordinates 0, 0. Let's say that point B is at position 3, 4 with coordinates 3 and 4. And then let's define C with coordinates 3, 0. Okay? Now, I want you to tell me the coordinates if I rotate the triangle 90 degrees counterclockwise with respect to the origin as the point of rotation. All right? So pause the video and try to see if you can figure out what the new coordinates are. All right, so I'll go ahead and work it out now myself. So if you rotate the triangle counterclockwise 90 degrees with respect to the origin, then the triangle is going to end up looking something like this. Okay? Now, to figure out the coordinates, let's call the points, let's call this C prime B prime, and let's call the other point A prime. To figure out the final coordinates, you can simply use the patterns we noticed on the previous example. So to find 3, I'm going to swap the original coordinates. So 3, 0 is going to become 0, 3. Okay? And because it's a counterclockwise rotation, I need to change the sign of the final x-coordinate. Okay? Negative 0 is still 0. All right, so that's fine. For B, I'm going to swap the positions of the 3 and the 4. Those are the original coordinates of B. So I get 4, 3. And again, I'm going to change the sign of the final x-coordinate. So B prime is at position with coordinates minus 4 and 3. Okay? And then A prime, the origin is still going to be the origin when you rotate about the origin. So 0, 0. All right, I hope those are the points that you found. Okay? Let's do one last example. All right, let's see. So I have another triangle. Let's call the points A, B, and C again. And I'll give it the following coordinates. Okay, this time I want you to do the following rotation. So how about a 90-degree rotation clockwise with respect to the origin as the point of rotation? All right, in fact, let's do 2. Let's also do 180 degrees counterclockwise rotation. With respect to the origin as the point of rotation. Okay, so let's call the answers, the vertices for the triangle that you end up with after the first rotation, let's call the vertices A prime, B prime, and C prime. And then for the second rotation, we'll call the vertices of the new triangle A double prime, B double prime, and C double prime. Okay? All right, so go ahead and try to work out those coordinates, please. Pause the video now. Okay, so I'll go ahead and work it out myself. So 90-degree clockwise rotation. So this triangle is going to end up looking like this red triangle. Okay, and so where are the A prime, B prime, and C prime? Well, we've got A prime right there, B prime right there, and C prime right there. And using our that pattern where you swap the coordinates, we can quickly see what the coordinates of A prime, B prime, and C prime are. Now, notice that unlike the last example, here we have a clockwise rotation. So I swapped the coordinates, but notice I had to change the sign of the final y-coordinate. Okay, so I hope you did the same. All right, and then 180-degree counterclockwise rotation about the origin. That will give us the following. So the triangle is going to look something like this. Okay, and you may recall the pattern there is that you simply switch the signs of the original coordinates. All right, so we've got here A double prime, B, A triple prime, A double, what am I thinking? Yes, A double prime, B double prime, and C double prime. Okay? A double prime is at the origin. Okay? B double prime has coordinates -2 and -4. I just changed the sign of the original coordinates. C double prime has coordinates -4 and 0. Okay? So hopefully that makes it a little bit more clear how to do rotation problems.